Here's the alternative proof. We're going to prove diagonals bisect each other. That'll show it's a parallelogram. That they're congruent. That'll show it's a rectangle. And perpendicular. That'll show it's a rhombus. We have to have the part where we show it's a parallelogram because equal diagonals do not prove rectangle. Perpendicular diagonals on their own do not prove rhombus. They only prove rectangle and rhombus in a parallelogram. So we got to show it's a parallelogram. All right, so we're going to show the actually, let's call that above our show because it's already written out. I mean, it's literally already written out. So let's just label that our show. All right. And now let's graph our figure. So 4, 0 is A. 0, 3 is B. I already have it written on here. C is -3, -1, and D is 1, -4. That negative is missing. If it were 1, 4, that would not be a square or fit on this coordinate plane. All right, so I am going to use a line tool here because that is by no means straight. All right, so I'm just going to connect the points. You do the same thing. Our first step is to graph the figure if it is not already graphed for us on a coordinate plane. Second step is to write down what we're going to show. The figure really gave us show, so we will take that show. All right, and then since we're going to be working with diagonals, let's graph the diagonals. Let's see if I can do this reasonably straight. Oh, not really. All right, that's not too bad other than the blip in this on the side there, but oh, that's awful. It's not even close to a straight line. Oh, I wish I could use a ruler. All right. I'll go slower. Still not very straight, but we'll take that. I didn't want it to be black lines again, so I'll take that. All right, we got our step 1, our graph. We got our step 2 because it was written into the problem. We'll take that as our show. Step 3 are the formulas. To prove the diagonals bisect each other, we need the midpoint formula. So the midpoint, we add the x's, divide by 2. And the y's, divide by 2, and that gives us the midpoint. We need, so to show the diagonals are congruent, we need the distance formula. Right, so x2 minus x1 squared plus y2 minus y1 squared. And then perpendicular, we need the slope formula. So difference in the y-coordinates over difference in the x-coordinates. All right, those are the formulas. All right, so now let's do the work. That's our step 4. I didn't write 3 in, but formulas was step 3. All right, so now let's prove the diagonals bisect each other. We have the diagonal AC. So let's find the midpoint of AC. All right, so that would be 4 plus -3 divided by 2, and oops, 0 plus -1 divided by 2. All right, so that's going to be 4 minus 3 is 1/2, and then -1/2. I'll just squeeze that in there. Trying to make sure I don't lose and save. I'm very careful with my space. And then we need the midpoint of BD. That's the other diagonal. All right, so that would be 0 plus 0 plus 1 divided by 2. So looking for the D there. And 3 plus negative 4 divided by 2. So that would be 1/2, negative 1/2. Right? We just added, right? We added 0 plus 1 and added 3 minus 4. All right, so we got the midpoints. Now we need the length of AC. So everything is with the diagonals. All right, we're not doing a thing with the sides. I actually like working with the diagonals because it's a whole lot of work to find the midpoint. I only have 2 diagonals, so I only need 2 slopes and 2 distances. So it's kind of nice. All right, so AC, the length of AC would be 4 plus negative 3 squared. Excuse me, 4 minus, wrote the wrong sign in there, 4 minus negative 3 squared plus 0 minus negative 1 squared. So that would be 4 plus 3. So that's going to be 7. And then we have 0 plus 1. Excuse me, 7 squared, 1 squared. So that's going to be 49 plus 1. I'll have to come down here now, which is the square root of 50. And 50 is 25 times 2. 25 is not prime. 25 is 5 times 5. So 1 5 comes out, 1 5 goes away. So square root of 50 is 5 square roots of 2. And now let's find the length of BD. So that's going to be the square root of 0 minus 1 squared plus 3 minus a negative 4 squared, which is negative 1 squared plus, that'd be 3 plus 4, so that's 7 squared. So that's 1 plus, square root of 1 plus 49, which is the square root of 50, which we already know is 5 square roots of 2. All right, so we got the midpoints, we got the length, we need the slope of the 2 diagonals, so we can show it's a rhombus. The slope of AC would be 0 minus a negative 1 divided by 4 minus a negative 3. So that'd be 0 plus 1, that's 1, and 4 plus 3, that's 7. And then BD, that would be 3 minus a negative 4, good enough, over 0 minus 1. So that's going to be 3 plus 4, that's 7, divided by negative 1, that's negative 7. And that's all our work that we need. Right? I'm going to do this one as a paragraph proof, and I think I might have enough space at the bottom. It's either at the bottom or I got to write it over here. Now maybe I'll put it over here. All right. All right, so ABCD, let's start with the parallelogram part, is a parallelogram because, all right, this is a symbol for because, if you want to write it smaller, both diagonals bisect each other. Because they have the same midpoint, or since they have the same midpoint. And we'll write the midpoint down. One half, negative 1/2. It is a rhombus. Actually, we did the work for the rectangle first. Let's say it's a rectangle. It is a rectangle because I'll use this symbol just to save some space, because both diagonals are congruent. And both AC is equal to BD, which is 5 square roots of 2. Actually, I'm going to write it like this. Let's write it each diagonal separate. So both diagonals are congruent. AC equals 5 square roots of 2. BD equals 5 square roots of 2. That's much cleaner and clearer, I think. All right, so it's a rectangle because both diagonals are congruent. And we already know it's a parallelogram. Therefore, congruent diagonals are going to make this a rectangle. And actually, I should say, I'm going to write this one more time, because I want to make it clear that we're not saying it's a rectangle because the diagonals are congruent, but because it's a parallelogram with congruent diagonals. So ABCD is a rectangle because it is a p-gram. A parallelogram. There, that sounds much better. Sometimes when you write it, it'll be like, oh, I didn't quite say that. You can always fix it because it is a parallelogram with congruent diagonals. AC equals 5 square roots of 2. BD equals 5 square roots of 2. I like that. Much, much better. And then ABCD is a rhombus because it is a parallelogram, which I'm abbreviating, with perpendicular diagonals. So we want to state that we already know it's a parallelogram each time, right? So therefore, all we need is one little additional thing to show it's a rectangle or a rhombus. The slope of AC was 1/7. Slope of BD is -7, right? So those are negative reciprocals. Which are negative reciprocals? Let's add that in, because that's what shows that they are perpendicular, which are negative reciprocals. Oh, I'm running out of space unless I only got one more sentence. How about we move it up just a little bit? Oh, that's all by itself. Well, that's a good chunk. Whoops, but that didn't move up. All right, piece by piece, we'll move this up. You can just move over to the side. Since I used up all my space, I'm going to have to move this up. Well, meanwhile, you can finish writing in your notes while I'm moving them all up. Oh, I still don't have enough space. Well, that's okay. We will move this over here. There, that'll extend the page. I think it'll look better if I extend the page. Let's extend the page. Okay. ABCD is a square because it is both a rectangle and a rhombus. So once you've shown it's a rectangle and a rhombus, you can say it's a square. And there we go. That's the end of the proof. All right, so this one is in sentences. If you're doing the same kind of proof, so I'm going to move this up a little bit, you can either write it as a paragraph proof like I did here, or you can make it a 2-column proof by just changing those sentences to phrases, right? And modeling the other proofs. All right, thanks for watching. Bye for now. This is my last square proof. So I like to do either, so notice that I either deal with just the diagonals, right? Or I deal with just measurements. Right? I think those are the two easiest ways to do the square proof. All right, well, bye for now.